Weather Workshop.
For the audio, he's just shown.
1011 Weather Workshop. Hello, hello. Testing 1, 2, 3, 1, 2, 3.
Your guys would like to get that going.
Okay. You sound lovely. Okay, the live is on. Going on yet though, but not yet.
Hello there. I'm meteorologist Brett Anderson, and today, this is our second 1011 Weather Workshop, and we're going to be talking about the seasons. Why do we have the seasons on the Earth? Winter, spring, fall, summer. Maybe you have your favorite season. Some people like winter, some people like summer. But again, this is a very interesting planet that we live on, because some of the planets in our solar system don't have seasons because of their orbit, and that's the key reason, is because of the tilt of the Earth's axis. That's the main thing. So that's what we're going to talk about first, is the tilt. So these are the seasons, and of course we just had spring. Spring just started last week. That is actually called the vernal equinox. So when we talk about spring beginning, it's what is called the vernal equinox. So again, we'll zoom in here, and this is what's happening in Earth in the relationship to the sun. So this is the equator. Remember, if you look at a globe, there are lines. So we have the equator, we have the northern hemisphere, and we have the southern hemisphere. So it just kind of divides that. Now this is a line called the Tropic of Cancer, and this is the line called the Tropic of Capricorn. So these other lines will become important as well. But right now we're talking about spring, the vernal equinox. Now usually that occurs right around March 20th. It's not every year March 20th. This year, at least in Nebraska, Central Time, it started on the 19th. Sometimes it's the 21st, the 22nd. Now the center of the sun is directly over the equator. So this is the sun down here. This is the direct lay. So most of the energy is going right along the equator here. So again, that's what we have there. Now this is what is happening. So the Arctic Circle, by that time, we're up here, the North Pole, is about 12 hours. In fact, everyone is seeing about 12 hours of daylight and 12 hours of nighttime. So the Tropic of Cancer gets about 12 hours. That's that. The equator gets about 12 hours. And the Tropic of Capricorn, about 12 hours. And then the South Pole, Antarctica, also about 12 hours. So again, that is the vernal equinox. That is when spring begins. That is where the sun is shining most of its energy, the direct rays, at the equator. So now we're going to move into summer, all right? And now, again, the first day of summer is usually around June 20th. It's not all the time, but usually right around June 20th. Well, now look what happens. As the Earth continues to revolve around the sun, now the direct rays, this is indicating the sun, is now shining directly on the Tropic of Cancer. It's not on the equator anymore. It's on the Tropic of Cancer. So now most of the energy is now in the northern hemisphere, or the direct energy is more on the Tropic of Cancer, but you'll also notice as the Earth rotates, most of the direct sunlight or more energy is now receiving the United States, is now hitting Nebraska. So that is why we start to warm up, because we get more direct energy from the sun. Now, meanwhile, while our summer is starting in the northern hemisphere, in the southern hemisphere, places like Australia, South America, that's when their winter begins. So it's opposite. Northern hemisphere, summer begins on June 20th, around then. Winter begins in the southern hemisphere. So long days in the northern hemisphere, this is where the sun doesn't set till 9 o'clock in some areas, even a little bit later, a little bit earlier across the United States. And then in the southern hemisphere, the days are very short. So a little more information, the amount of daylight at the Arctic Circle or the North Pole, the sun doesn't set. It is sunny or clear or daylight, if you will, the entire period. So this is the summertime. Tropic of Cancer, again, that's this line right here. It goes through places like India, northern Africa, southern portions of the United States, Mexico. They're getting about 13 and a half hours of daylight. The equator is about 12 hours again, but the Tropic of Capricorn in the southern hemisphere is only getting about 10 and a half hours of daylight. And then the Antarctic Circle or the South Pole is dark, completely dark at this time. There's no sunrise, there is no sunset. So again, that's the summer. Now, of course, we're going to transition into fall, which usually occurs right around, well, actually we skip fall, we're going right into winter. So again, this is winter, and maybe did I go back too far? Okay, let's go through this again, because we should see the vernal equinox, and then we're going to do summer, which we did. So just kind of going around the sun again. And then we're going to go to the summer solstice, which we talked about. And then we're going to go to the winter solstice. So we did skip fall. But this is what's going to happen in the winter. We'll talk about fall in just a little bit. Now, as winter begins for the northern hemisphere, which is about December 21st, you'll notice that the direct sun, or the energy, the most energy, is Tropic of Capricorn. So that is when summer begins. Summer begins for Australia and portions of South America. But in our area, the northern hemisphere, that's our winter. You'll notice again, the sun is down here in the southern hemisphere, but not as much direct energy is heading into the northern hemisphere. So basically, we have our winter conditions. Now, a little bit more, we have the short days, of course, in the northern hemisphere. The sun rises later, sets earlier. Long days in the southern hemisphere because it is summer there. So the Arctic Circle, or again the North Pole, no sunshine or no clear skies, no daylight, I should say, is what we're really talking about, because, again, which we'll show you in a little bit, the sun is not reaching there because of the tilt of the axis here on the Earth. So again, the Tropic of Cancer is about 10 and a half hours. The equator is about 12 hours, and then summer, as you head into the Tropic of Capricorn, it's 13 and a half hours, and then the South Pole, it will have daylight for the entire time. No sunrise, or no sunset, basically, this summer. So that's basically what's happening, and we're going to talk a little bit more about this. We're going to show you kind of a fun little model here. This is going to represent the sun, all right, this big old bouncy ball here, all right. It's kind of greenish, but just pretend that it's big and yellow, all right. And then again, here is the Earth. Now, as you'll probably realize that this is not to scale. The Earth is not that big in comparison to the sun. In fact, you could actually fit 1.3 million Earths inside the sun. So in reality, at this point, compared to this ball, the Earth would be just a tiny little dot. But again, so you can see all this, this is what we're going to do. All right, so the Earth, it's on its axis here, and it's always pointed in this direction, 23.5 degrees. That is actually the tilt, 23.5 degrees. So at this particular moment, this is winter. Now see, this is the United States right here, and there's the sun, but right now, the sun's direct rays are all down into the southern hemisphere, or the direct rays on the Tropic of Capricorn. So we're receiving less energy from the sun in the wintertime. That's why it gets colder. And meanwhile, up here at the top, the North Pole, the sun never shines. It can't shine it. The rest of the earth is blocking it because of the tilt. It's tilting away. So that is why we have the winter here. Now, of course, the earth goes around the sun, revolves around the sun, and then we start spring. This is the vernal equinox. Now again, the sun's rays are now directly on the equator. So fall is beginning in the southern hemisphere, but spring is beginning in the northern hemisphere. So we start to slowly start to warm up. And it's this transition of seasons when we start to see the stormier weather. Ken Shimmick talked about severe weather season. It's because of the change of seasons. The warmer air trying to return, the colder air still moving south from time to time. That's when we start to get to the stormier weather, but we also start to see warmer conditions, leaves on the trees, the flowers start to grow, the grass turns green. Now we continue to revolve around the sun, and now it is summer. So here's the United States, but again, as we rotate, the direct rays more in the northern hemisphere. The intensity of the sunshine is more in the northern hemisphere. Tropic of Capricorn, look at the North Pole. Now it has sun. So as the earth rotates, the sun never sets because it continually shines on the North Pole. That is why the days are longer as well. Now doesn't stay light all the day as we head into Nebraska, but we certainly have those longer days and shorter nights during the summer. So again, this is the summer, United States, most of the sun's energy right into the northern hemisphere. All right, and we'll continue. And now, of course, you know the next one. It is fall, the autumnal equinox, and it's basically kind of the same thing as spring. The sun, the most direct energy, is right at the equator, starting to turn to spring in the southern hemisphere, and then the northern hemisphere, we're starting fall. So things are going to start to get cold, and this is where we have 12 hours of daylight at the North Pole, in Nebraska, as well as the equator, southern hemisphere, and the South Pole. This is when it's equal. So again, that is basically how the seasons work as they go around the sun. Now, if we were not tilted 23.5 degrees and we were just like this, we would not have seasons on the planet. It would literally be like the middle of spring or the middle of fall here in Nebraska. So yes, it would be warm, but it would be cold. We'd never really get anything growing. We'd never really have a summer season for the crops to grow, for other plants to grow, for food to grow. So, and most people, if we didn't have seasons, if we didn't have that tilt, would probably end up being around the equator because they would be warm, and the North Pole and the South Pole would actually be even colder than they are now because there would not be direct sunlight during the summer. There really wouldn't be much of a variation. It'd probably stay about the same, which would be very cold. So that's one of the reasons that's a good thing, why we have seasons, why we have that 23.5 degree tilt on our axis, so we can experience the seasons throughout the year. So that is why we have the seasons. It's all because of the tilt. And again, so basically, we're done with that. Now, if I can find my clicker here, because I want to show you another thing. Where did I put my clicker? Bill Rensler, did you take my clicker?
I did not.
Is that okay? That could be over there. There's so much room. So I'm going to move this stuff out of the way. Whoop, don't drop the sun, Bill. Now you dropped the sun. All right. Now, some of you might have heard when we talk about on the weather, like meteorological spring or meteorological summer. But what we've been talking about so far is astronomical seasons, the astronomical seasons. So that's all based on the Earth's position when we talk about astronomical seasons. So it's relative to the sun. We've talked about that. Begin at a solstice or an equinox. Again, when summer begins, that's called the summer solstice. When winter begins, that's called the winter solstice. And again, the vernal equinox is when spring begins, and the autumnal equinox is when fall begins. So the seasons last about 89 to 93 days, around 3 months, of course, due to leap years and Earth's elliptical orbit can change some of that. Now, when we talk about meteorological spring or summer or fall or winter, it's a little bit different, and this is why we do it. It's based on the annual temperature cycle, all right? So winter is December, January, and February. So it starts December 1st, will end February 28th or February 29th if there's a leap year. Summer is all of June, June 1st, July, and August. And then, again, the seasons last about 90, 92 days. And, of course, spring is March 1st to May 31st, and fall is September 1st through November 30th. So the reason why we have a meteorological season or climatological season, if you will, is just easier to calculate seasonal statistics for anyone, basically, but especially for agriculture and commerce. So that's basically why we sometimes talk about meteorological season. And, you know, if you think about it, when you think about summer, you just kind of think it's June, July, and August. And so that's kind of why we have the meteorological season. So it is different from the astronomical season. So that is about it for the presentation. And we were opening up to any questions that we may have. Do we have any questions?
We want to know what your favorite season is, Brad.
My favorite season is summer. When I was a kid, I loved winter, but as I'm getting older and the cold hurts me more, I tend to enjoy the summer months a little bit better.
There were also some good questions, but I don't know if they're a little bit out of our depth as to why the Earth's tilt is 23.5 degrees. How did that happen?
I do know the answer to that, believe it or not. You're shocked, aren't you, Bill? There's a theory that there was a large size planet or asteroid about the size of Mars that actually hit the Earth and actually forced it to about 23.5 degrees. Now, there is a little bit of a wobble in the Earth's tilt. Right now, we're at 23.5, but at times during Earth's history, it's been as little as 22.5 and as much as 24.5. So right now we're at about 23.5. But over the centuries and the millennia, we do have that wobble in our revolution, or I should say revolt, or the tilt is what I'm trying to say.
Why does the Earth spin?
That is because of gravity.
I would agree with that.
Yes.
How does the sun stay hot?
Because there are millions and millions of tiny little nuclear bombs going off. And that's serious. I'm not lying about that, but that's just the best way to describe it. It's fusion. It's just like a fusion bomb. They're just it uses hydrogen for the energy, and then it converts that to helium. And someday, maybe about 4.5 billion years from now, all that hydrogen will be gone. And that means the end of the sun. But again, we don't have to worry about that for a while.
That's future Brad's problem.
That's right, exactly.
There was, so you said summer was your favorite season, but a lot of people want to know, what about fall?
I like fall. I do like fall. I like the colors, Halloween. But again, it starts to get cold. And so that's why summer.
There was a good question about leap years, since this year is obviously a leap year.
Mm-hmm.
Not necessarily how it affects the seasons, but it certainly affects our calendar.
That's right. Why do we have leap years every 4 years, a leap year every 4 years? It's basically because the revolution around the sun takes 365 days. That's 1 year. But it's actually 365 and a quarter days. So if you add those quarters up, 1 year's a quarter, 2 years is half, 3 is 3/4, and then what do you have 4 years later? You have a whole extra day on your hand. And if we didn't have that leap year, everything would start getting messed up. So basically, we have to add that day every 4 years to keep things in balance.
Not necessarily seasons related, but Blake would like to know why you became a weatherman.
I have always loved weather since I was a little kid. In fact, it was probably a winter blizzard back in 1975 that really got me going weather. I was living in Iowa. It was the January blizzard of 1975, and we had a lot of snow and 70-mile-per-hour winds, and we were trapped in our house in Iowa. We couldn't go anywhere, and I think just the intensity of all that just kind of started getting me interested in weather. And so by the time I became 9, 10 years old, I started watching the weather on TV and started reading books from the library, and I just something that I've loved probably ever since I was 9, 10 years old.
Another good question. What is you kind of talked about it, but what is your least favorite season?
Again, winter is probably my least favorite. Now, don't get me wrong, I still enjoy certain things. I enjoy stuff from every season. I just find that winter, again, a little painful. December, Christmas, all the lights, the festivities, I like that. And, the snow, I mean, it's okay, nice, pretty snow. It's just that's kind of fallen down a little bit on the list of seasons.
I don't suppose you know how fast the Earth spins.
Not off the top of my head.
It's really fast.
It is really fast. It's a good thing we have gravity, because then we would fly off.
It's kind of like when you're riding in your car and everything's going by really
yeah,
fast.
It really is. It is that fast, yes.
Do you know why the seasons are called what they're called? I don't know that one.
I don't know that. I mean, maybe fall is called fall because the leaves fall off. That's my best thing. Vernal equinox, autumnal equinox. That's a good question. I think one of these things we could do is maybe we could answer these questions on Facebook once we have a chance to research that. So that's a very good question, though.
Yes, we'll try to get back to that. Amy wants to know, what's your favorite kind of weather?
Favorite kind of weather? I like thunderstorms. I mean, I don't like severe thunderstorms. I mean, we don't necessarily like that because they can be damaging. But a nice little thunderstorm, a little bit of a wind, a little bit of heavy rain, a little bit of lightning and thunder. That's probably my favorite. I do like the occasional good snowstorm, but of course I like days like yesterday when it was 75 and sunny. Those are very nice as well.
Luke has a good question. Why do the leaves fall off the trees?
That is a good question. It's kind of a combination. It's actually partly due to the lack of light. As the days are getting shorter in the fall, the chlorophyll that makes the leaves green is not produced anymore. But also in combination with that, as the temperature cools, that also begins to change the chemistry of the leaves. So you have a combination of the cooler weather, the longer nights, less daylight, starts to get those things changing, and that's why we have the colors.
There's some good questions.
I'm sure.
Karen wants to know, will the Earth explode?
I don't think the Earth will explode unless another planet, Planet X, comes in from another part of the galaxy and hits the Earth. More than likely what will happen, as I mentioned earlier, how the sun, once it uses all its hydrogen and is mainly filled with helium, it'll actually expand into a red giant, and they don't know for sure. It either will just get us very, very hot and everything will bake off and we'll just be a hot rock in space, or the sun might even consume the Earth, and then the Earth would be eaten by the sun. Astronomers don't really know for sure which one will happen, but nevertheless, in 4.5 billion years, things aren't looking good for the Earth.
Carrie, you kind of touched on this, but there's been a couple questions. Carrie and Cindy wanting to know about seasons on other planets like Mars.
Yeah, that is a good question. Mars does have seasons. Mars has a tilt of about 24.5 degrees, so about a degree more than the Earth. Now, it also takes Earth, or rather Mars, 2 years to Earth's 1 year. Basically, a Martian year is Earth 2 years, so twice as long. So it takes a lot longer to go around the sun. Therefore, its seasons are different. Now, because the tilt is more, the seasons are different lengths. And basically, you have summer, or spring. I wrote this down. Let me get this here for you. I was wondering if we would get a question about this. And here's what happens. Because of the tilt, spring on Mars is 7 months long. Now, remember, it's taking 2 Earth years for 1 year on Mars, so that's why. So spring is 7 months long. This will make you happy if you live on Mars, because summer is 6 months long. And then fall is 5 months long, and if you don't like winter, winter is 4 months long on Mars. So different tilt. It is farther away from the sun, so even on a summer day, along the equator, it might get up to about 15 degrees Fahrenheit, but then because of the very thin atmosphere, it drops to about 100 below at night. So it's not necessarily a comfortable place.
I'm supposed to say if you could just repeat the questions because they can't hear me.
Oh,
Yeah,
from now, that's a good point.
Amy wants to know, why does the weather change so fast from day to day in Nebraska?
Especially in spring, we kind of talked about that. The question was, why does the weather change so fast day to day in Nebraska? And basically, it's because of the jet stream. That's one of the reasons. And sometimes with that transition of winter, spring, the summer, the jet stream can really intensify because of that temperature difference between, again, the warming of the southern part, or the sun, of course, is starting to warm things up in the southern plains or southern part of the northern hemisphere. So you get this tightening of the jet stream, the pressure, and that can give us bigger storms or fast-moving cold fronts. So yes, so basically you have 75 degrees yesterday, you have a cold front move through. There's still cold air lurking in Canada. Even though it's spring now, it's still very cold. In fact, some parts of northern Canada still 30 degrees below zero. So there's still cold air in there, and that's why spring can be so variable with really warm days and other days really cold. In fact, I think March is one of the more variable months where we have record highs in Nebraska, Lincoln, around 90 degrees, but we still have record lows well below zero. So March is a month that has very big swings in temperature.
We only have time for a few more questions.
All right.
JC wants to know if the changing seasons have an effect on animals.
What's the name? What's the person?
JC?
JC wants to know if the changing of the seasons have any effect on the animals. And they do, but the good thing is they're used to it. They know about it. It's an instinct. They know what to do. Starts to get cooler, or they start to notice the lack of sunlight. Birds, a lot of them, will fly south. Kind of the same reverse when it starts to get warm. Sandhill cranes know it's time to head back to the north, so they come up from the south and head back into Canada. So animals know. I mean, some things are even happening that they don't even know it, like some fur. The fur starts to thicken up, obviously, as you get closer to winter for a lot of the mammals. And then, of course, they shed the mammals again as you head into summer, so it's cooler. So it's all kind of natural, and they've all evolved that way because of the seasons. If we didn't have seasons, the animals would have evolved in a different way.
Amy wants to know what's the latest it's snowed in spring.
Amy wants to know what's the latest it has snowed in spring. Now, I know in Lincoln, the latest it has snowed is, I believe, May 3rd, which we had back in 1967, but we had one a few years ago, which I think was around May 2nd. So that's the latest measurable snowfall in Lincoln. I'm not 100% sure about Nebraska. I do know that there was a big snow event back in the 40s that happened around Memorial Day in portions of northern and western Nebraska. So there's that situation. I can tell from personal experience, when I was a younger man, it snowed on the first day of summer. Now, I was in the mountains of Colorado, but it actually did snow several inches on the first day of summer. So it all kind of depends on where you are and where you live, your elevation, how far north you are, to when that last snow actually could happen.
And then probably just the last one, there's been, again, some other questions about feeling the seasons and why do we have weather. Can we just do like a quick recap of what you talked about?
What was the first part of what you said?
Can you feel the seasons?
Feel the seasons.
And like why we have weather.
Let me tell you, when that north wind blows in December and it's feeling like 25 below, I feel it. So yes, you can feel it. It's not, sometimes it's so subtle you really don't know the changes. But again, especially when you start losing daylight, some people don't like that. They like those long days, and they can kind of get sad as the daylight gets shorter and shorter. Winter is very short as far as daylight, so that can be sad for some people without that lack of daylight. And the second part of that question, just the recap again. Basically, we have seasons on this planet because of the tilt. 23.5 degrees, revolves around the sun, always pointing the same way. The summertime, we have more sun in the northern hemisphere, so that's why it's hotter in Nebraska. But in the wintertime, Now, again, I'm not going to go around the sun, but just imagine that I did. Now you have most of the energy in the winter in the south. It's summer in the southern hemisphere, but winter in the United States, winter in Nebraska, because we're receiving less energy. The sun angle's even lower. So that's why we have seasons on the planet. If we did not have seasons, it would be a much different planet, and some argue we might not even be here, the animals and plants, if we didn't have seasons, because things would have evolved differently. So that's, I think that's it. I think that's all we have time for. I think if you still have questions, you can still write the questions, send the questions via Facebook, and we'll try to get those answered off the air here. So don't worry, we'll answer your question if we didn't get to it. So yeah, we're very excited about this. Hope you found it informative. This will also be available, I believe, on our 1011 Now weather page. A little bit later on, you'll be able to watch it later if you need to, or if you want to send a link to somebody. So again, thank you very much for watching, and catch, Bill. All right. We'll see you next time.